Okay, so on the first notes handout, this is just to help solidify some of the content that we were just discussing in the notes. And it is pretty straightforward, but we'll run through the majority of the problems together. So if you take a look at numbers 1, 2, and 3, all you're doing is writing the ratio of the angles. So they tell us to find the cosine of theta. Well, cosine is going to be your adjacent side over your hypotenuse. And in this case, we don't have our hypotenuse, so we're going to have to use the Pythagorean theorem in order to solve for our hypotenuse. So to do that, if I call this C, then this is going to be C squared is equal to 4 squared plus 13 squared. So this is going to be C is equal to the square root of 16 plus 169, which is going to be 185. And so if I try to simplify 185 down, I can't, because if I divide it by 5, I get 37 and both are prime. So when I write the cosine of theta, then the cosine of theta is going to be my adjacent side, which is 13, over my hypotenuse, which is the square root of 185. But you have to rationalize the denominator. So to rationalize your denominator, you're going to multiply the top and bottom of your fraction by your denominator to get that radical off the bottom. And so you're going to end up with 13 square root of 185 over 185. In number 2, where you're finding the sine of theta, it's a similar setup. Here's my theta. And to find sine, I'm looking for the opposite over the hypotenuse. So I'm going to need to know this side. So if I call this side A, well, I used the Pythagorean theorem from Monday. So I'm going to have A squared plus the square root of 71 squared is equal to 11 squared. So this is A squared plus 71 is equal to 121. And when we subtract 71 from both sides, we get A squared is equal to the square root of 50, which is going to simplify down, because if I factor 50, it's 2 and 25, and 25 is a perfect square. So this is going to be 5 square root of 2. So the sine of theta is equal to my opposite side, which is 5 square root of 2, over my hypotenuse, which is 11. And the only other thing we check for is we check to make sure we don't have to rationalize the denominator, which we don't, and we check to make sure that our fraction can't be further reduced, which it can't. Okay, I'll leave you to try number 3 on your own. Similar setup, but with tangent, you're working with the opposite over the adjacent, and you have to use the Pythagorean theorem to find it. For numbers 4, 5, and 6, you are labeling the sketch and solving the right triangle. So when you solve a right triangle, you have to find all of the missing parts. So they tell us that the measure of angle A is 39. So when we label our triangle, if we always make C our right angle, then the measure of angle C is 90. So I have A, B, C, and this is going to be 39 degrees. And if angle A is 39 degrees, it says, it even gives you the hint, use the triangle sum theorem to find the missing angle. So to find the missing angle, I am going to set it up as the measure of angle B is equal to 90 plus 39. And you're going to subtract, I should have wrote that second, you're going to subtract that from 180. And so it ultimately ends up being that you're going to subtract 90 or 39 from 90. So the measure of my angle B is going to be 51 degrees. And then to solve for one of your missing sides, and it doesn't matter which one you solve for, what I know is that my hypotenuse is the square root of 17. And so my sides, if I call this little a because it's opposite angle A, and this little b because it's opposite angle B, then I can use a trig ratio in order to solve. So I know the measure of angle A, it's given to me as 39. So what I do is I say, okay, well, the sine of 39 is equal to my opposite side, which is A, over my hypotenuse, which is the square root of 17. And so when I'm here, I'm just going to solve for A by multiplying both sides by the square root of 17. And in doing that, this leaves me with A is equal to the square root of 17 times the sine of 39. And when I'm here, I just let my calculator do the legwork on this. And so it says round your answers to 2 decimal places. So from here, A is approximately equal to 2.59. So from here, I can use the Pythagorean theorem to solve for my remaining third side, since now I know 2 sides, or I can use another trig function to find the last side, because I know that the cosine of 39 is equal to my little b over my hypotenuse. So it's an almost identical setup, except you're using cosine instead of sine. So this b is equal to the square root of 17 times the cosine of 39. Okay, so this gives you approximately 3.2, which if you set it up using the Pythagorean theorem, you'll end up in the same place. So numbers 5 and 6 are set up in a very, very similar fashion. I will take a look at number 6 with you. You can try number 5 on your own. With number 6, what you're given are 2 side lengths. So I'm going to call this A, B, and C again, making C my right angle. So this is going to be 90 degrees. And my 2 side lengths are going to be 2 and my hypotenuse 6. So if I use the Pythagorean theorem to find the remaining third side, then I'm going to have 6 squared is equal to 2 squared plus b squared. So this is 36 equals 4 plus b squared. And I subtract 4 to get b squared is equal to 32. And then when I take the square root of both sides, then I have b is equal to the square root of 32, which simplifies down into, this factors into 2 times 16. And the square root of 16 is 4, so 4 square root of 2. And if I put that in the calculator and round it off to 2 decimal places, then I'll get 5.66 approximately. Now, it says to use an inverse trig function. So this is one of those instances where you are solving for the angle measure. So if I start with angle A that I want to solve for, I'll call it theta. Then I know that the sine of theta is equal to 2 over 6, because it's equal to my opposite over my hypotenuse. So when I solve for theta, then I have to use the inverse of sine for 2 over 6. So when I put this in the calculator, I'm still going to use the sine key, but I have to use second sine to get that inverse function. And I just evaluate it for my ratio. And theta is going to be approximately equal to 19.47. So angle A is about 19.47. And then from here, this triangle sum theorem, the measure of angle B is 90 minus 19.47. So this is going to give me 70.53.